Hello and welcome to this webinar presented by PIC Wire and Cable. My name is Matthew and I will be your Global Spec moderator, and I want to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The windows with the heading Presentation are the primary windows for today. On the right side of the screen is the speaker bio window with background information on today's presenters. On the bottom left of the screen is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Now I'd like to introduce today's presenters. With us today, we have Rob DeGrave, the Director of Product Management and Marketing, coming to us from PIC Wire and Cable. And we also have Todd Wilson, Product Manager, also coming to us from PIC Wire and Cable. To read more about our presenters, please look at the speaker bio window right next to the main presentation window. And guys, welcome to today's event. And with that, I will pass things along to you to get started.
Thank you, Matt. Hello and welcome, everyone. Thank you for joining us today for our webinar on uncovering weight savings, lightweight interconnects for aviation emission. I'm excited to guide you through this important discussion. As the aviation industry strives to achieve net zero emissions, the focus on weight reduction has never been more critical. Newer aviation platforms are constantly pushing the boundaries of technology, efficiency, and sustainability. Today we'll explore how a key component of your systems, cables, connectors, and harnesses, can significantly contribute to these goals. As we all know, the aviation industry is committed to achieving net zero emissions by 2050. This ambitious goal requires us to rethink every aspect of aircraft design and operation, focusing on efficiency and sustainability. Innovations in propulsion, aerodynamics, and materials have been pivotal, but there's another area that offers substantial weight-saving opportunities: interconnect solutions. The Intergovernmental Panel on Climate Change, known as the IPCC, estimates that aviation accounts for roughly 2.5% of all human-generated CO2 emissions. Experts project that from 2021 to 2050, aviation emissions will amount to nearly 21.2 gigatons. In 2021, the aerospace and defense industry are committed to a greener and more sustainable business model by 2050. This initiative also supports the Paris Agreement's goal of limiting global warming to 1.5 degrees Celsius. In February 2024, the Federal Aviation Administration released a final rule requiring manufacturers to include more fuel-efficient technologies in airplanes made after January 1, 2028. This new rule is expected to deliver significant environmental benefits. Estimates suggest that it could reduce carbon dioxide emissions by as much as 1.4 billion tons over the next 50 years, equivalent to planting 74 billion trees. Conversely, the interconnect requirements for business jets and military aircrafts have evolved over time to have more and more technology on board. This has caused the size of the cable harness to increase. These additional systems cause an increase in the total payload of the aircraft and create more emissions. By optimizing these systems with lighter cables and connectors, it is easier to justify this technology to reduce the weight of the aircraft and offset emissions. The drive toward reducing CO2 emissions has introduced a lot of uncertainty in the industry, particularly regarding fuel sources like sustainable aviation fuel, electric batteries, and hydrogen. These fuel types affect the entire aerospace ecosystem, from aircraft development to airport infrastructure. For example, aerospace companies are hesitant to develop hydrogen-powered aircraft unless airlines commit to purchasing them, and airlines are equally reluctant to invest without the necessary refueling infrastructure in place. As you can see, change is not possible until the entire value chain has been synchronized to achieve zero emissions. However, very recently, Archer and Southwest agreed to develop operational plans for electric air taxi networks in California airports, with the goal of offering door-to-door trips anywhere in California in 3 hours or less. This signifies the importance of everyone adopting to meet these emission goals by 2050. As the International Air Transport Association has estimated, SAF can reduce CO2 emissions by up to 80%. However, the question remains, how do we achieve the remaining 20% reduction? A leading aerospace sustainability engineer recently noted, "We have SAF to get us to net zero, but there are other things we should be pursuing." Numerous modifications can be done to reduce CO2 emissions. One simple and effective way to reduce CO2 emissions is by modifying your current interconnect systems. Such modifications can bring dramatic weight savings to your onboard systems, reducing both emissions and fuel costs. By future-proofing your avionics with lightweight cables and connectors now, you can minimize labor and downtime when transitioning to new fuel sources. Interconnect modifications are also crucial during fleet renewals, especially when upgrading electrical systems. For example, a leading helicopter manufacturer tasked PIC Wire Cable with reducing coax cable weight on one of its airframes. Each helicopter used 809 feet of coax cable, and the goal was to reduce 59 pounds from the airframe. By installing ultralight 50 ohm RF cables, which weighed only 29 pounds, the customer achieved a 51% weight reduction, saving 30 pounds overall. With electric and hydrogen fuel options adding significant weight to the aircraft's total payload, it is crucial to focus on weight reduction in other areas to offset this increase. For instance, electric-powered aircraft require substantial energy to take off, climb, descent, and landing, which depletes onboard battery power. By reducing cable weight, you can conserve battery power, leading to increased productivity and profitability. Let's investigate the impact of lightweight interconnect cables and connectors in an emerging aerospace market, the Advanced Aircraft Mobility, also known as the AAM market. This market is a growing sector of aviation that focuses on new aerial transportation solutions that are more efficient, sustainable, and accessible than conventional aircraft. Some of the vehicles in this market include unmanned aerial vehicles and unmanned aircraft systems, electric vertical takeoff and landing (eVTOL) aircrafts, electric short takeoff and landing aircraft, and electric conventional takeoff and landing aircraft. These vehicles will be used for emergency medical services, military reconnaissance and combat, tourism flights, passenger routes, and can even be used to make deliveries to your home. When selecting interconnect components for the AAM market, the process is far more complex than for consumer drones. The scale of these advanced aircraft requires aerospace-grade interconnect solutions that can meet the stringent demands of larger, more sophisticated machines. For example, fighter drones can weigh up to 1,300 pounds and carry substantial payloads, unlike consumer drones that typically weigh around 40 pounds. These UAVs rely heavily on advanced GPS and ground control systems, requiring robust electromagnetic interference protection to ensure reliable communication. Weight optimization is essential in this market. For example, an eVTOL aircraft with a standard weight of 4,300 pounds and a maximum payload of 1,000 pounds benefits significantly from lightweight components. Reducing the weight of the interconnect systems can lead to more economical fuel consumption, greater speed potential, and longer flight durations. A lighter payload minimizes lift force and thrust requirements during flight, conserving energy and extending operational range. For example, Joby recently completed a 523-mile flight with its hydrogen electric fuel source with no in-flight emissions. This groundbreaking flight showcases the market's potential for emissions-free regional travel, connecting cities like San Francisco and San Diego, or Boston and Baltimore. It also landed with 10% of its hydrogen fuel load remaining. The relationships between weight and other design variables have a cascading effect. For example, reducing the weight of the integrated avionics system reduces the overall mass of the UAM aircraft, which reduces disk loading. That, in turn, reduces the power needed to maintain rotor speed, which reduces battery size and ultimately reduces the vehicle's overall weight even more. Key takeaway: less power means less charging time and more availability of flights, which results in smoother operations. For military, commercial, and business aircraft, maintaining a limited payload is vital, and optimizing interconnect solutions is key to meeting weight restrictions. Every ounce shaved off an aircraft translates into lower emissions and an increased payload capacity, allowing for more passengers, cargo, or equipment, and enhancing operational capabilities and profitability. By focusing on lightweight, high-performance interconnect solutions, the AAM market can continue to advance toward a sustainable, efficient, and profitable future. Now, Todd is going to discuss the lightweight interconnect components that you should consider for your aerospace applications.
Thanks, Rob. When thinking about reducing aircraft weight, cables and connectors might not be the first components that come to mind. Yet these components are crucial for the functionality of the modern aircraft, ensuring reliable communication, power distribution, and control systems. The cumulative weight of cables and connectors can significantly impact overall aircraft performance, affecting fuel consumption, emissions, and operational efficiency. At PIC Wire Cable, we are committed to helping you achieve substantial weight savings by optimizing these crucial systems. Modern aircraft designers focus intensely on advanced technologies to enhance fuel efficiency and gain a competitive edge. OEMs challenge their engineers to leverage aerodynamics and lightweight materials, while engine manufacturers strive for cleaner burning technologies to improve fuel efficiency. At PIC, we understand the critical importance of weight reduction in aviation. By focusing on materials design and advanced technologies, we help identify hidden weight-saving opportunities within the interconnect solutions. Assigning a value to each pound of weight in an aircraft is complex due to numerous influencing factors. However, it is evident that reducing weight aligns with the primary goal of aerospace industry stakeholders. Governments benefit from reduced CO2 emissions. OEMs gain from extended range and payload capacity, and aircraft owners enjoy lower cost of ownership. Let's look at the amount of cabling in an aircraft. Conventional aircraft can contain between 70 and 300 miles of cable, depending on the model. For instance, the Airbus A380 has about 328 miles of cable, while a Boeing 787 contains around 60 miles. This means that all of the cable from a wide-body passenger jet were laid end-to-end. They could connect cities like St. Louis to Chicago or London to Amsterdam. Also, if the cables and their harnesses were rolled into a ball, it would weigh around 16,000 pounds, or about 3% of the aircraft's total weight. This presents a significant opportunity for weight reduction. Let's also consider the operational costs. The average yearly fuel costs of emissions for operating a business jet. We'll assume the average jet is estimated to be in use around 480 hours and burns about 500 gallons of fuel per hour at a cost of $6.33 per gallon. This adds up to a yearly estimate of over $1.5 million worth of fuel costs and around 2,300 metric tons of CO2 emissions. As you can see, reducing aircraft weight can have a substantial impact on fuel costs and emissions, making it a priority in the aerospace industry. Now that we can see the impact of cables and connectors have on weight of the aircraft, let's see how we can optimize these solutions to help stakeholders achieve their emission goals. Selecting the right lightweight cable and connectors for your application involves navigating through numerous variables. Engineers have many requirements that they must meet before they can select a product. First and foremost, the cable needs to be designed to be airworthy. This is why PIC only sells cables that have passed FAA burn smoke requirements. Then the engineer must carefully consider other factors, including EMI levels, shock, vibration, and temperature variations within the environment. Choosing the right cable construction is crucial for optimizing your interconnect solutions. It's essential to align the cable's design with the specific requirements of your application. Selecting a lightweight cable without considering its performance characteristics and installation environment might not deliver the desired results for your avionics systems. When evaluating cables, start by assessing key factors such as loss budget, operating frequency, and the length of coax cable. For Ethernet, focus primarily on data rates, protocol, and run length. Once these parameters are defined, you can select optimal interconnect solutions to meet your needs. PIC offers a wide variety of cables, allowing you to choose the best options based on your aerospace requirements. This ensures performance and durability when minimizing cable diameter and weight, which is crucial for fitting cables into tight spaces and reducing the overall aircraft weight. Understanding the unique challenges of aircraft environments, PIC designs its cables, connectors, and assemblies to perform reliably in constrained and demanding conditions. This approach ensures that our products meet the specific needs of aerospace applications, contributing to overall weight reduction and system efficiency. PIC offers 12 sizes of our standard 50 ohm coax with options of solid and stranded wire gauges, ranging from 26 gauge to 10 gauge. For additional weight savings, PIC created ULTRALITE, which provides 4 additional 50 ohm coax cables to reduce cable weight even more. Routing cables in aircraft involves navigating various obstacles such as tight turns, bends, bulkheads, and other cable harnesses. The cable's quality is crucial during this process, as a tight bend radius can cause kinks that disrupt the cable's signaling characteristics. Maintaining proper impedance is essential to prevent issues with VISWAR, voltage wave standard ratio, and signal loss, which can adversely affect system performance. At the same time, flexibility is key. When choosing cables, consider options that offer sufficient flexibility to simplify routing. For instance, identifying a more direct path to the line replaceable unit, or LRU, can reduce the amount of cable needed, thereby decreasing the size, weight, and length. Traditional solid dielectric cables can be heavy and rigid, requiring more cabling for complex routing. In contrast, PIC's ULTRALITE RF coax cables incorporate air into the dielectric, allowing for a smaller diameter and greater flexibility, which simplifies complex routing. Once the cable is installed, high-quality connectors are essential for maintaining signal integrity between the cable and the termination point, while also being easy to terminate. PIC offers a broad range of connectors and contacts to meet diverse integration needs. Our MACHFORCE and quad connectors are engineered to optimize swap for size, weight, and power, providing robust, lightweight solutions that ensure reliable performance without sacrificing ease of installation. These connectors are crucial for enhancing system efficiency and performance. By focusing on the cable's bend radius and flexibility, you can streamline installation, minimize weight, and ensure reliable performance even in tight spaces. Our sale application engineers regularly conduct weight-saving analysis to determine how much weight can be reduced through optimized interconnect solutions. For example, a recent project involved reducing the weight of an avionics system. By utilizing PIC-MATE's ULTRALITE 50 ohm coax cables, we achieved a 43-pound reduction in the interconnect harness weight. This weight reduction led the customer to explore further weight-saving opportunities across the aircraft to lower fuel costs and emissions. We know that weight savings analysis is one of many steps in the long process of qualifying cable for flight. To streamline this process, we provided detailed drawings, EWIS, electrical test results, and CAD models to the customer. This provided the necessary tech data to qualify our cable for all zones on the aircraft, which ultimately allows PIC to achieve its #1 goal of making the customer's job easier. In today's aerospace and defense sectors, there is a growing demand for faster data speeds, more streaming content, and advanced sensors to collect data, all of which must be delivered in real time. This demand places additional strain on aircraft interconnect systems. As new systems are integrated, the weight of the electrical wiring interconnects increases. To address this, we need to go beyond fuel efficiency and lightweight materials and consider innovative solutions. A promising development from the automotive industry is the use of single-pair Ethernet cables. The automotive industry, facing similar challenges with harnesses weight due to the increasing sensor loads, collaborated with IEEE to develop the 802.3 BP protocol. This protocol enables gigabit speeds on a single pair cable rather than a 4-pair configuration, effectively halving the cable's weight and size. We are excited to announce our new single pair Ethernet cable capable of full duplex gigabit data transmission. For comparison, our flagship gigabit Ethernet cable E50824 weighs 5 pounds per 100 feet, while the new single pair Ethernet cable weighs only 2.3 pounds per 100 feet. This innovation is set to transform the aircraft interconnect systems by offering significant weight savings and additional benefits. Single pair Ethernet simplifies topology, streamlines maintenance, and allows for easier reconfiguration, contributing to both weight reduction and operational efficiency. Innovation in lightweight interconnect solutions is crucial for the aerospace industry. However, managing signal integrity remains a challenge. High-speed protocols and system operation at high frequencies are susceptible to EMI, which can disrupt signals, leading to data corruption and reduced system performance. PIC has decades of expertise and works closely with aerospace companies. Our product offerings have empowered our customers to select the ideal shielding construction for their specific applications. Signal degradation or interference happens when electromagnetic fields from one signal disrupt neighboring signals. This will lead to signal distortion, data corruption, and reduced overall system performance. EMI can also arrive from sources such as radio frequency emissions, electronic devices, power lines, and lightning. This can interfere with communication, navigation, and sensor systems, jeopardizing the safety and effectiveness of the equipment. In defense applications, aerospace cables can require additional protection against electromagnetic pulses to prevent sensitive electronic systems from threats as well. There are many ways we can protect against EMI while designing a cable while still optimizing for weight. We can add more shields, change the gauge of the braid, increase or decrease braid coverage, utilize different types of materials, and even change the way we install the material onto the cable. Let's look at a few examples of what these shielding options look like. The 50 ohm ultralight coax cable construction has two shields. We use silver-plated aluminum round wire braid to reduce the weight and a helically wrapped shield to increase shielding effectiveness. The round wire braid provides more than mechanical strength for crimping connectors. It protects against lower frequency ranges as well. We also pair the braid with a second foil shield that is helically wrapped to protect against higher frequencies. When these two shields are paired together, you can achieve a higher level of shielding effectiveness. Our goal is to balance shielding effectiveness with cable flexibility. Increased braid coverage improves shielding, but can make the cable heavier and stiffer, complicating routing. As a product manager, I ensure our cables are both easy to work with and robust enough to endure harsh aircraft environments. We vary braid gauges and coverages to strike this balance. By focusing on innovative lightweight interconnect designs with superior shielding, engineers can better manage the challenge of high data rates and video streaming in aerospace applications. These solutions not only help to reduce the risk of EMI and interference, but also contribute to the overall system efficiency by reducing weight, which in turn helps to lower emissions. In this way, advanced interconnect technology plays a crucial role in meeting both the performance demands of the modern aircraft and the environmental goals of reducing the aerospace industry's carbon footprint. To address the challenges faced in high-temperature environments, let's investigate the electronic components in a UAV by exploring the harsh environmental conditions that these systems operate in. UAVs, especially those designed for advanced applications like defense and high-speed reconnaissance, must operate reliably even at elevated temperatures. These conditions can cause thermal expansion and material fatigue, potentially leading to system failures if not properly managed. Moreover, the operational environments of these UAVs are incredibly harsh, with some systems required to perform at speeds approaching Mach 5. At such extreme speeds, the forces exerted on the aircraft are immense, leading to significant shock and vibration stresses on all onboard systems. The interconnect solutions used in these high-speed UAVs must not only withstand these conditions, but also ensure continuous, reliable operation. And aerospace and defense equipment is expected to have a long service life. Cables are no exception to this requirement. They must be designed for longevity and reliability to minimize maintenance requirements and downtime. Choosing cables crafted from top-tier materials that also have undergone rigorous testing ensures this reliability. Standards have been established along with rigorous testing by various associations, including EWIS, FAR, ASTM, FAA, NEMA, RoHS, Skydrill, and SAE, which verify the performance of interconnect cables in these challenging environments. Focusing on lightweight, high-performance materials that can withstand extreme conditions allows manufacturers to help drive innovation in the aerospace sector while also reducing the carbon footprint of these advanced systems. An often overlooked weight-saving option is laser marking technology. Traditional cable labeling methods such as tags or printed labels can add unnecessary weight. Laser marking eliminates the need for additional labels by printing directly onto the cable jacket. For technicians, clear and durable markings are crucial for quick and accurate cable identification during maintenance and repairs. Laser marking reduces the time needed for tracing the troubleshooting connections, leading to faster repairs and minimizing aircraft downtime. By incorporating laser marking onto cable design, manufacturers provide solutions that are lighter, more durable, and better suited for the demanding conditions of modern aerospace applications. As avionics and systems evolve, it is crucial to regularly reassess your interconnect solutions. Understanding system requirements and evaluating cable construction ensures optimal performance and supports ongoing advancements in aerospace technology.
By partnering with PIC, we can help you reduce the weight of the cables in your aerospace systems, leading to significant reductions in fuel consumption and carbon emissions. Our dedication to innovation and quality drives us to deliver customized solutions that meet stringent technical requirements while minimizing aircraft weight. PIC has a dedicated team that will work with you from design to installation. Our team will be able to help you select the perfect cable from our comprehensive product line of 74 cables and 335 connectors, designed for various aerospace systems that include networking, navigation, in-flight entertainment, and communications. This vast product offering includes 50 and 75 ohm coaxial and triaxial cables, Ethernet cable solutions, data bus cables, and USB and HDMI cables. PIC ensures that each product is engineered to solve unique system requirements in the aerospace and defense market. PIC's 50 ohm coax and triax cables, including our ultralight cable, offer lightweight cable solutions designed for applications requiring low loss, high performance, and durability in harsh environments. These cables are engineered to meet the demands of high-frequency data transmission with a focus on reducing weight while ensuring reliability. While PIC's 75 ohm coaxial and triaxial video cables are designed to be lightweight, low loss, and flexible, ensuring reliable performance in aircraft systems. We engineered a larger conductor for these cables to streamline the termination process. By exceeding stringent industry standards, they save valuable weight on your missions, simplify routing, and reduce operating costs. Our 100 ohm shielded Ethernet cables are available in 1 to 4 pairs. Power over Ethernet and Quadrex configurations are all built to support high-speed data transmissions up to 40 gigabytes, with protocols ranging from Cat5e to Cat8. This diverse range of cables ensures that you have the right Ethernet cable to meet your high-speed data requirements in mission-critical applications. Our USB cables are designed for harsh aerospace conditions that deliver transfer speeds up to 10 gigabytes per second, ensuring uninterrupted, reliable communication in critical applications. While our aerospace certified HDMI cable with Ethernet meets stringent standards for consistent, high-quality performance, making it ideal for high-resolution video applications that can support 4K resolution while simplifying networking with integrated Ethernet capabilities. PIC's expertly crafted assemblies not only reduce the weight of your aerospace systems while meeting rigorous performance standards, but also offer a plug-and-play solution for easy integration. Our manufacturing facility boasts extensive engineering expertise, including designing, manufacturing, testing, and assembling harnesses and assemblies. Key capabilities include overmolding, skilled termination, custom laser marking, mechanical testing for shock and vibration, phase matching, VSWR testing, and complete lot traceability with serialization. Trusted for over 50 years, PIC Wire Cable has defined the standard for innovative, lightweight solutions that contribute to emissions reduction while meeting the rigorous demands of aerospace and defense sectors. Thank you for your time today.
Thanks, guys, for that great presentation. And now we're going to be moving into the Q&A session. To the audience, if you haven't sent in your question yet, you can still do that now by adding it to the Q&A box on your screen and pressing the submit button. We already have a number of great questions in the queue, so we're going to get to those right now. If we don't get to your question, we will reach out to you after the webinar is over. So please send in your questions or your comments. Okay, now for our first question from the audience. Are there particular materials or technologies in your cables that contribute most to weight reduction and performance enhancement? Guys?
Thanks for that, Matt. In fact, there is. Whenever you're designing a cable, it's a little bit like a puzzle. There's trade-offs. You really have to take into account mechanical, electrical, and environmental where it's going to be, used in the aircraft. And when we're doing that, we make sure that all three of those have a nice balance between them. And so when we are using certain materials to accomplish lightweight, we have to go through rigorous testing to make sure that they'll actually survive in the aircraft environment. So we like our conductors to have be silver plated because that's a great conductor for electrically. We also look at materials where you can use, thin wall jackets, but also that it'll pass, the rigorous routing through the aircraft while still being self-extinguishing. As well as we've put it through other types of testing that are usually we'll see in EWIS certifications that our customers require.
Excellent. Thank you for that, Todd. And thank you for that question. Please keep them coming. Okay, moving on to our next question from the audience. Can you give examples of where your single pair Ethernet are being used on a certified aircraft?
Yeah, that's a great question. As of right now, the industry is looking at this. So it's a promising technology that's really going to revolutionize and make our harnesses smaller. We're a little bit actually ahead of the game right now. They're talking about it, in on commercial aircraft. It might be used eventually. Right now we're kind of waiting for the LRUs and the boxes that will have network cards and things like that to catch up to the actual networking standard. But it does look like it's coming, and we're happy to have the product, and I'm sure it'll be here before we know it.
All right, thank you for that. To the audience, we are in the Q&A session now. You can still send in your questions by typing that in the Q&A box and clicking submit. Even if it's just a comment, we would love to hear from you. Now, we just received a bunch of questions, so just give us a moment here. We're going to choose the next one. And while we're doing that, I also want to call out, you may have noticed on your screen, we have a lot of additional information, and there's also a way you can click on the bottom right corner to schedule a meeting with the team. So if you want to follow up, you have some more conversation, you want to find out more, we do encourage you to do that. Also, you'll notice the resource list. We have a number of great resources in there you can click on and take home with you. And then across the bottom of the page, you'll see a series of buttons with even more information from the PIC Wire and Cable team. So if you need some information from this team, you want to know what's going on, we definitely encourage you to follow up there and keep this conversation going. All right, let's get back to the questions. And here is our next question from the audience. How do you how do your interconnect solutions integrate with existing aircraft systems?
Yeah, that's a good question as well. When we're designing our cables, we always want to make sure they're field terminatable. So a technician can have a new system that maybe they're integrating into an existing aircraft, and we want to make sure that it's not going to have big bulky connectors on it, so that as it's being routed, they may get hung up. So we really like to give the power to the customer. They can route it unterminated. It'll as soon as they get to where they need to go, they can quickly terminate it on the aircraft, and then with our nice termination instructions that lay it out very nicely, and then plug it into the LRU, and hopefully everything goes well.
Excellent, thank you for that. Okay, moving on to our next question. Okay, here it is. We have a large engineering team over here. Do you offer assistance with drawings, testing, or other technical needs?
Yeah, I'll take. Yeah, absolutely. Our application engineering team. I mean, we're eager to help with whatever your specific project needs are. Whether you need a technical assistance for a specific cable or for connector, or if you'd like PIC to design assembly specific for your application, we're here. We're your partner to help you through it.
That's awesome. Very good. Yeah, that question actually came in 3 different times from various people, but we decided to focus on that one there. And so again, on your screen, the audience, if you want to reach out directly right now, you can click on the button to schedule a meeting with the team on the bottom right corner there of your screen. All right, moving on to our next question. Okay, and here it is. How does PIC Wire and Cable ensure the reliability and durability of its cables and connectors in the harsh conditions experienced during flight?
Yeah, I'll take that one. So we look at it from a holistic approach. You know, we're going to use materials that we know are going to pass burn and smoke. They have to be self-extinguishing. We're really, you know, flight safety is critical. But from there, you know, we want to try to push the way that they're being actually used when they're being manufactured. So what we do is during the way the manufacturing process and the materials as they're being put together, we really have to. I'm sorry, Matt. Can you repeat the question?
Oh, absolutely, no problem. Yeah. Let's see, where were we? Yes. How do you ensure the reliability and durability of the cables and connectors in harsh conditions that are experienced usually during flight?
Yes, that's right. So after you choose your material process and you manufacture it, after that, we always send it out for burn and smoke testing, as well as do some other types of external testing with labs, usually around EWIS requirements. Again, you know, you have to have you know, there's shock and vibration, and there's flexing, and a lot of other different types of tests that we do. And we have, you know, we have to make a qual test plan and then perform the tests and then have a report as well for them. And our customers really enjoy that.
And in addition to that, anything that's industry standard through the test specifications that we have, if there is a customer specification specific one, there's a lot of customers that have specific test specifications for their specific products. We will be happy to discuss those requirements with you and do that testing as well.
That's great. That's really helpful. Sounds like you're almost an extension of their team in a way. That's awesome. Very good. Okay, to the audience, we are still in the Q&A. We have our experts from PIC Wire and Cable sitting in front of you ready to answer your questions. So if you have any questions for the team, something we may not have covered that you're wondering about that's related, you know, we'd love to hear about that too. So please submit that question. We have a few more in the queue we're going to get to in a moment here. If we don't get to your question for whatever reason, we will reach out to you after the webinar is over. Okay, let's get back into it. Okay, here's our next question. Can I use my existing connectors?
Yeah, we're aware of other connectors that are out in the market. The rigorous requirements that we were just talking about before, due to that, we don't recommend that. Our cables and connectors are certified together. Our connectors specifically certified with our cables. In addition to our assembly solutions, we don't recommend that you would use our connectors with any other products but ours.
Let's see here. Okay, great. Here's our next question. I have a unique requirement for our new avionics system that hasn't been met by other providers. Can PIC offer a tailored solution?
Yeah, absolutely. PIC, we are your premier industry partner for designing custom and unique interconnect solutions. We recognize the industry is really not a one-size-fits-all as much as we want it to be. And customized solutions on whether it's cable bundles and non-standard connectors are very common. So that's exactly where we fit in, and we're excited to be part of that.
Thank you for that. And that may have been our last question. We're just going to give it a moment to the audience. If you have any last questions or comments, now would be a good time to send them in. Just wait a second here. While we're waiting for that, I just want to remind everybody there will be a replay. This entire webinar, including the Q&A session that we're in now, will be available as a replay over the next 90 days on the Global Spec site. You can use the same link that you used today to access the replay. So if you wanted to share this with your team, your colleagues, we do encourage you to do that. Okay, and I think that was our last question. So we are going to move to wrap things up right there. Once again, guys, thank you so much for the presentation, taking some time to answer some questions from our audience. And of course, we'd like to thank our audience members for being part of this event. You will be receiving an email from us with a link to the on-demand version of the presentation. So as I mentioned, you can come back and watch this again. And lastly, if you can, please take a moment to complete a survey, which will appear on your screen at the end of this live webinar. For on-demand viewers, you will find the survey located along the bottom of your attendee console in the survey widget. Again, thank you for taking the time to attend this webinar event. Take care, and we will talk with you soon.